Let's see what we got here. Put well, hopefully this will do the trick. So what we got going on here is we have a Neptune 3 Max with custom Klipper firmware to make everything fully functional. And I'm going to be offering this with everything that you need. Okay, so it's going to have the image that you will burn using Raspberry Pi Imager and the instructions to the SD card that comes with your BTT Tech Pad. It's also going to come with the firmware that is pre-configured for your Neptune 3 Max to operate with Klipper, and it's all matching per the version of Klipper and Moonraker and everything else that's running on this Klipper instance with that firmware. And it's fairly new. This firmware is, let's see, it's all up to date as of 3/17/2025. Okay, so I just made this very freshly. Let me see if I can move this out of the way real quick. So as you can see, everything's up to date. Everything's up to date here at this moment. So what's nice about this setup is I've already gone through everything, debugging it, where everything works in regards to not only having Klipper working, but having all of the KAMP features working as well, such as auto bed meshing, smart park, smart purge, and things along those lines. And we'll give you an example right now of how this works. So we're going to find some basic G code and some other features I have in here set up where the pause function works both for the filament runout sensor. So if you have filament run out, it'll go into a park position and lock the motor so they do not move when you're inserting filament on like the Z axis, right? Z axis or Y axis. No, it'd be the Z axis. So basically, as you're trying to insert filament, it can't move up and down. And throw everything off so when you go to resume print, it'll layer shift and things like that. You won't have that issue with this. Let's find some G code to test. G code files. So we'll do a basic XYZ cube. And this is also configured, as you see, when I'm going to hit print right here, I have it where it'll turn the LED on to around 90% duty cycle. And then when your print stops, it'll automatically shut that light off. This will not only help, preserve a little bit of power, but on these Neptune 3 Maxes, when that light is on, it generates enough power draw to keep the fan running on the board constantly. So it's a nice feature to have that it turns itself off both when you have a finished print job or if you have to cancel a print, and we'll show you how everything works. So we're going to go print. It's doing some auto homing. I also forgot to mention, not only am I including the image that you can burn straight to the BTT Tech Pad, but you're also getting the vertical orientation of the BTT Tech Pad. And I can also send a link for the STL files for the mounting bracket that was designed by someone else. We'll give them credit for it, but off the top of my head, I cannot remember the name. Here in a minute after we're done, I might pull it up on the web browser. So next, we're going to let it do its thing and heat up. It's going to take a little bit of time for this process because the bed always takes a little while to heat up. It's targeting 70, I believe 70 C. Yeah, so that's going to take a minute. So while we got that going on, we'll pull up some other stuff and I'll explain it. Okay. 3D printer firmware. So I want to say I'm going to have this all available in a zip file. I'm also including the start G code for Cura and Orca Slicer. Start and end G code, I should say. So this is the star G code, and all you would do is you would enter this into Cura. First, you would clear out the star G code that is there for your printer after you get it set up. You select your printer and whatnot, and this is the NG code you will add into Cura. So if we pull Cura up right now, see if I have time while it's heating up. It might take a second for this. Okay, so it opened in another window. So basically, when you have your Neptune 3 set up, you go to, you select your printer through the drop down, manage printers. You choose the one that you're working on, go to machine settings, and then here is where you'll clear out the original start G code and paste in the G code that I have set for you in the text file, and then the same thing goes for the NG code. Okay, you want to paste that, remove the original and paste that in here. And then after that, this will work with no issues at all, no bugs, no glitches. And also, it wouldn't be a bad idea. There's a plugin you can install, I believe, called Connect. It's a Moonraker plugin. It is available in Cura that will let you upload your files directly from Cura, which is pretty cool. And then the same thing applies to Orca Slicer. So we will pull up Orca Slicer right now. The G code is different, not by much, but it is slightly different for the start and end. We'll pull up Orca right now. Orca boots up a little bit faster usually. All right, so we'll just open up an existing project to give you guys an example. You'll basically choose your printer, Neptune 3 Max. I have a custom profile for our 0.6 nozzle because for whatever reason, no one has updated the profiles yet for the Neptune 3 Max. They only offer the 0.4 nozzle originally, and mine is set up with a custom 0.6 nozzle. So you would click on here to edit your machine settings, go to machine G code, and here is your start and end G code that you would clear all of it and paste in the G code that I provided. So basically you would start here in this section, stop here for the start G code, and then you would just basically highlight all of this and click copy and then paste that into the end G code for Orca Slicer. And this will prevent you from having any issues, because this is, I'd say, the biggest issue everyone has is just getting the G code just right to work on different platforms, especially Orca Slicer. I know personally I struggled with this forever, and that's why I am giving you guys this for free, right? So everything's pre-set up just for this exact printer image. So let's go pull up the browser. So right now, it's auto meshing. We'll pull up the height map right now. And it's meshing based on the size of the print itself. And if we look in the dashboard, we can see it's not a very large print. It's just a 20 by 20 cube. So we'll pull the height map back up. It should be almost done here in a second. And the way I have this, it'll kind of be a little bit more detailed in the smaller meshes. So we'll show mesh. See how many points it probed in that mesh. I want to say it's like 11 by 6 or something along those lines. I can't remember off the top of my head. It's one of those things where I'd have to reference, again, my printer config settings. Okay, so we get that. We'll go back to dashboard right now. It is already starting the print. Down thing to Orca Slicer. This file that we started printing was originally sliced in Orca Slicer, and for my taste, the initial print layer speed is a little bit too aggressive. Typically, I would like to see slower speed. I usually set it down in the 40s, but just as for reference for this video, we're going to give an example. Okay, so now we're going to show you how some of the functionality. So we're going to come up here to pause print. We hit pause. It's going to finish what it was doing on the last movement. And as you come over here to the side, as you can see, we have our purge line and the print starting. We go back to resume. And it doesn't take very long. Like I said, the video feed is delayed. So it's already starting to print up again. And as you can see, the light is on. And then to cancel the print, we're going to hit pause again. It's going to finish its movement. It's going to move back over into the pause position. Okay, just like that. And then you can hit cancel. It shuts everything down. And after everything is shut down, it shuts the light off. The motors are able to move freely. It's going to go down into the next stage of like the cool down process. Now, some other features of this as well is while the bed's warm, we will do a manual bed tramming. So this feature was already in the original printer config that I modified very heavily because there was a bunch of issues with it. There was issues in regards to pausing, starting, stopping, things along those lines. And it didn't have any of the KAMP feature set as well. But I renamed it to the proper name because it did say originally manual adjustment, but now it says manual bed tramming, which is the proper terminology. And what it's going to do is it's going to home, and then all the corners where you have your adjustment screws, it's going to show you where they need to be adjusted at. So last time I checked, mine was already pretty close, but we'll give you an example. We'll make this a little larger maybe. I apologize about issues on video feed. It seems like I'm having a few issues. What those are is it's moving the sensor right above the screws and measuring the bed height differences. So now we'll show you this right here. So this right here, it shows that I need to turn the back screw if you're standing up looking above it, right? If I'm above the print bed and I'm looking at the screw, I need to rotate it in the clockwise direction. Not very far. So this right here is, think of it like as a clock time base. So you'd be like 5 minutes, 10 minutes. You'd only move it over in the distance of like a 10-minute difference. To the right, this one, the right middle screw needs to go left 13 minutes on a clock, which is counterclockwise. Same thing with the 8 and the 16, 14, the 6. It's not terribly off on the differences in the Z height offset. I could probably dial these in just a little bit more. And basically what you do is you accept those values and then you retry again. You can get those measurements and make bed adjustments again. And another feature I've added is I've added a macro. Okay, so when you get this image, one thing you're going to want to do immediately is you're going to want to check your Z height offset, because I have a custom nozzle and a few other things in my printer that are custom, like the linear rails and stuff like that. It's not going to be the exact same height as yours. So if we go into like machine settings, printer config, let's see, printer. So the max or minimum position allowed for Z offset is 0.5 millimeter, which I had to do that for my setup because I want to say on average it does fall a little bit below the 0 value. But I also commented right here that to show the value previously was 0. Let's see. Z home. So my offset is right here for the X, the Y. Let's see. Well, anyways, the offset's in here somewhere. I'm just trying to make a quick video. You can look through it if you want to. But anyways, before you even start printing, I made a very simple macro called manual Z offset. Okay, so what this is going to do is when I click this, it's going to auto home the head. Okay, and then it's going to move it into the exact position of my current Z offset. Okay, so it's not going to, you're not going to risk, as the head is going to be moving around during your print and having to manually adjust your offsets right here as it's in live time, which is a great feature. It'll show you where you currently stand before you start printing. So you're going to want to click your manual Z offset adjust. So like I said, it's going to home. And then after it's done homing, it's going to move the head in the exact position of my offset. Okay. And if it seems close to you, go ahead, run it. Typically you would want to use a piece of paper and kind of measure the distance under the tool head. And all you have to do to make the change to it, if it's too tight, see it moved, it's going to move down now into its Z offset position. So what you would do, if you're happy with that, go ahead and run it. If you're not happy with it and you think it's too tight, what you can do is you can pick the bed up a little bit like this. It's not the downside to Klipper though, it will not let me do this adjustment in live time. So what you would do is adjust your Z offset a little bit. For example, mine's too tight just a little bit. So I'm going to go up, 0.01, right? And then you click save. And when you go to save, it will go to your Z offset has been calculated and registered. Click on the save config to save the printer config and restart Klipper. So you'd hit save config, right? It's going to reboot Klipper. And as it reboots, you're going to have your new Z offset set. Okay. And then you're going to want to test it again. So you go back here to manual Z offset adjust, you click it, and you repeat the process. If the piece of paper is too tight or too loose, you make a slight adjustment, you save it, let it restart, check it again. And essentially just want a tiny bit of drag on that piece of paper and you're pretty much dialed in. And then I'm going to just hit manual Z offset adjust. And it's going to proceed to home again just like it did last time. And now it is currently in that position. That feels better. It's looser than it was before, but just enough to be snug on the paper. So I think I'm going to be happy with that, and I'm going to leave that offset. So once you've done that step, you're good to print. Like I said, you want to enter those slicer settings that I am going to provide, and this is all going to be for free. Once you do that, everything will work as normal. So let's start preheating this. So we'll show you how this works in live time. We'll go Cura. You know what? We'll pull up Orca Slicer instead, because it already has a few things I've tested on this. What's really cool too is Orca Slicer. If you like Orca Slicer, which a lot of people do nowadays, it seems to be everyone's favorite. We'll open up this previous project that I sliced. So we'll do strength. That's already 15%. Crosshatch pattern. That's all good. Speed. Initial layer 40. That seems fine to me. But you can also, because now you're running Klipper, you want to look for your device as it's attached to your network. And you can do that within the Big Tree Tech pad. You can just connect your home network, And when it's connected, you should be able to find the IP address. And when you find that IP address, let's see, you have to click on here. You click on the Wi-Fi button. You enter your IP address for your device, running Octo, Klipper, or you could just say Klipper, doesn't really matter. Okay, and now we can see the device also within Orca. So instead of having it open in a web browser, we can see it as it's happening right here. So what we will do is slice plate. Okay, plate is sliced, and we'll go print and switch to device tab after upload. So upload and print. Seems okay, and it's uploaded. Yeah, the print temp is a little high. I probably should have adjusted that down, but like I said, this video initially is just to show you that this is a very fine-tuned version of Klipper that is custom made just for the Neptune 3 Max. If you want a version for the other versions of Neptune 3 so you can convert them into Klipper, I will show a video on how to do that. Basically, all you would have to do essentially is adjust all of your printer dimensions to match your printer. But if they're all running the Robin 3 Nano board, this is all going to work the same. And one thing before I forget, this is also pre-configured for input shaping, and a base input shaping calibration has already been added. If you decide to increase the speeds, I do have the speeds limited on the Neptune 3 Max because I noticed that because it's such a big printer, when you try to accelerate it that much, it's very hard for that smaller bed motor to keep up and keep that bed held back when it's slinging at higher speeds. So the way this is configured is for nice, smooth operation. It's not going to cause you any issues in Klipper with the Neptune 3 Max. But like I said, I'll bring it up on camera right now. The input shaper sensor is configured and hooked up for the BTT Pad that is included in the kit when you buy it with the CB1. Initially, you'll have it hooked up to the head first. It'll pulse back and forth, and then you hook it up to your bed next. After that, you are going to want to adjust the speed settings. So you would want to adjust the speed settings initially to allow for a good resonance test for input shaping. Because like I said, I do have the speeds limited based on the Neptune 4's or Neptune 3 Max's bed slinging capability. Because if I get too out of hand with it, it kind of ruins everything. So anyways, I'm going to provide the file. I'll provide everything. I'll show you in the folder now. Let's see. Okay, so what I'm going to provide is I'm going to provide this zip folder right here. Okay, so in the zip folder, it's going to include the SD card Klipper firmware. Okay, so this right here has already been renamed, and all you have to do is have a properly formatted SD card in FAT32 format. Drop this on the SD card with your printer powered down and insert it in the SD card slot. Okay, power your printer back up with the handheld controller disconnected from your printer, and you'll know it works because your overhead light won't initially come on immediately anymore. When you switch your printer on and off, the light's not automatically on. And, it doesn't take long. I'd say maybe give it a minute just on the safe side after you switch it on with the SD card and the new firmware inserted into it. Then you can power your printer down. After you power your printer down, feel free to go ahead and hook the BTT Pad with the custom image installed on the SD card. So, and here is the Klipper firmware, okay? This right here has been compressed. You have to use a 32 gigabyte SD card for this, which is what I want to say the BTT Pad7 comes with anyways. So you can just kind of clear it off, right over it with Pi Imager. And I'm going to leave instructions on how to do that, which are right here. So it basically tells you what you need and how to go about it. That's basically it right here. You're more than welcome to read through it. I'm just not going to do that right now for the short video. And also, as a bonus, I'm going to include the updated Marlin software for the Neptune 3 Max, and or all of the Neptune 3 line essentially. So we'll open it right now. So this is the board firmware, which is literally the board, the control board, the Robin Nano. And this is the screen firmware. And you have to make those match when you install them. So you will have to pull your factory screen apart, remove that SD card, insert the firmware, and so on and so forth. But this is basically steps on how to do that and go about that process. It has all of them here. 3 Max, 3 Plus, and Pro. So if you ever at any time want to revert back to Marlin instead of using Klipper, I'm including that as well in the file. And all of this, like I said, is completely free. Let's see how it's doing now. So we'll check height map and look at that. There's our height map for the print, which as you can see, it measured out within a 5 millimeter boundary around it. And something I want to note out is this is also custom KAMP code as well, okay? Because the original KAMP code was having issues with Klipper and it was interfering. And what was happening is everything was working. It would do its little purge line in the wrong place because it was losing tracking. And it was losing tracking because of how KAMP was originally set up for smart bed meshing. It would offset somewhere else over here and start the print further back. And when it would lose, because it would lose its position, when the print would be finalized, it would be basically forcing the bed too far forward in a position it cannot do, things like that. So I've already ironed out all the bugs in it. And I do plan in the future to include more features, such as, I'm pretty sure they already work anyways. The webcam function does work if you hook up your own camera. But you have to manually enter your information in your G code for your slicers that every layer you want it to take a snapshot. Which if you're familiar with the sonar stuff, this won't be an issue for you at all. But like I said, this is to be as simple as possible to get Klipper up and running on your Neptune 3 Max and other Neptunes. But this file specifically, you can upload this and use it on your smaller Neptune devices, but you have to change the printer config. And all you have to do in the printer config and the bed meshing and things like that is change your bed settings.